So in this video, I'm going to be showing you how to find the domain of a function, how to find the range, as well as where a function is defined, or when is a function said to be well defined. You get my point? Are these real functions of a real variable? Now, we want to look at these three examples. We want to check whether they are real functions, that is, they are defined on the set of real numbers. And if they are, where do they have a real function? Now, you have ln of x plus 2. In reality, the natural logarithm of x plus 2 is actually a real function, provided that what is inside, like the argument, must be greater than 0. So, this is a function, it's a real function. That's why I'm writing yes, but because the question says where do they have real functions, but x plus 2 must be greater than 0. That is where the natural logarithm is defined. Do you get my point? You can't have ln or logarithm of -1. It's not real. Do you get my point? It's not real. So logarithm of ln of -1 is not in R. Like anything less than 0, the natural logarithm does not exist in the set of real numbers. That is my point. So provided that s plus 2 is greater than 0, or you say s is greater than -2. So g of x is a real function in the interval. I would say g of x is a real function on, you see, greater than -2, and it goes up like that. That is from the interval -2 to infinity. That means from the set of -2 down to infinity, because that is what we have there. Do you understand? Now, for this f of s comma z to be equal to x squared plus z, in reality, this is also a set of real function. In fact, there is no boundary to this. S can take any value, z can take any value. So I will say yes on s comma z in the whole set in R2. Why am I writing R2? R2 simplifies that it has it's a pair rather. R2 means it's a pair. If it's just a function of a single variable, I'll write R. If it's function of two variables, I'll write R2. If it's function of three variables, like in this example, I'll write R3. Do you understand? So there is no boundary or limitation to this. So it's all fall on the interval on all the set of real numbers. Now the third one, the answer is also yes, but where is it valid? It is valid when everything under the square root. We have square root here. So now listen, the peculiarity for logarithm is that it has to be greater than 0. The peculiarity for square root, it has to be greater or equal to 0. So that means this is here is that it is a real valued function, but c plus ab minus 1, that's everything inside the square root, must always be greater than or equal to 0, because if they are not greater than 0, they will be less than 0, and you will be having complex numbers, and that's not in R. They are not real numbers. Do you get my point? So I can as well say c plus ab is greater than or equal to 1. So I can say that this is a real valued function on a comma b comma c, since that is the domain. It's a three valued function, three variable function. It's inside R3 such that this condition must also be satisfied, such that c plus ab is greater than or equal to 1. That is what we have for this first three example. Now let's look at how to find domain. Now we are told to find the domain of the functions of the following function. The first example, I have m of x. We want to find the domain of this ln of 1 over ln of ln s, right? So I am going to rewrite this. Don't forget ln, note that ln when they say ln s is actually log s to base e. So ln is a logarithm function. So every law of logarithm will work for ln as well. So what is my point? So if we have ln of maybe 1 over p, for example, this is same thing as ln of p raised to power minus 1. The power can come behind to become minus ln p. That is from the law of logarithm. So that's what will happen here as well. This is equal to of ln ln x, as the question is given, raised to power minus 1. That's what we have there. The minus can come to the back, to the front, to become minus ln according to the law of logarithm. Then I have ln of x. Don't forget, I told you something on the previous example. I told you for a logarithm to be defined, is defined when the argument is greater than 0. If it's not greater than 0, if it's 0 or less than 0, it is not defined, or it is not defined on the set of real numbers. So that means that everything here, to find the domain, don't forget I'm looking for the domain. Everything here has to be greater than 0 for this m of x to be defined. This is ln of something. So ln of that thing inside ln must always be greater than 0. That's the point for it to be defined, because if you press ln minus 4, it is not defined in R in the set of real number. Ln of 0 is not defined in R, but if you press ln of 0.1, it is defined. You get minus something. If you press ln of 7, ln of 100, I mean from 0 and above it is defined, but from 0 and below it is not defined. So this means that to find the domain here, all these ones I underline has to be greater than 0. It means that ln of x must be greater than 0. So this is log e. Then I also have another ln x there greater than 0. Do you understand? I'll let e come to the other side so that just the normal logarithm approach. This is ln x. I will have ln x to be greater than e raised to power 0 according to the law of logarithm. That's what I have done here. So that means ln s is greater than 1. Anything raised to power of 0 is 1. That is what it means. So I'll do the same thing again. That means I have ln s to be greater than 1. That ln is log s base e and is greater than 1. By the time I apply the law again, the base will carry the power at the other side according to the law of logarithm. So x will be greater than e raised to power 1. E raised to power 1 is e. So that means the domain, actually, I will say, is the set of real number s in R, everything in R, but s has to be greater than e before it can be defined. If s is not greater than e, it can't be defined. If I want to write it in interval form, I will say e to infinity, because s is greater than e. That means e and above. E is 2.78 or so. Do you get my point? That's the Euler number. So if I want to write it in terms of set, I'll say s in R so that s is greater than e, or I write it in the interval from e comma infinity. Let's come to the second example. The second example, I have k of x to be equal to ln of minus 1 over x. So again, to find the domain here, don't forget the peculiarity of ln. Everything here after the ln must always be greater than 0. So to find the domain here, it means that minus 1 over x must be greater than 0. If you take away this minus, that is multiply both sides by minus. Whenever you multiply both sides by minus, inequality change. 1 over x will be less than 0. That is what it means. So if you have 1 over x to be less than 0, it means that this is negative. 1 over x negative. So for 1 over s to be negative, 1 over s is less than 0. It means anything less than 0 is a negative number. So 1 divided by a number, if s is positive, if this one is positive, let's say maybe 2, 1 divided by 2 can never be less than 0 because it is positive. So my point is that 1 over s is less than 0. It also means that s is less than 0. Do you understand my point? Because s has to be a negative number for the inverse to also be negative. Do you understand? If s is positive, let's say 5, 1 over 5 is not negative. 1 over 5 is a positive number. The implication is that s has to be a negative number before 1 over s will also be a negative number, so that the domain of this function says s in R such that s is less than 0. If I want to write it in interval form, this is s is less than 0. That means the upper bound is 0. So that means in interval form I'll write minus infinity to 0. That is where it is defined. Anything outside this function is not defined. That is the domain of that function. Now let's come to the third example. I have h of x to be equal to x plus 1 raised to power 1 over 3. So now, since I have raised to power 1 over 3, there's no problem, because if s is positive, we can take the cube root. If what is here is negative, for example, if I have minus 64 raised to power 1 over 3, the answer is minus 4. Why? Because minus 4 raised to power 3 will give me minus 64. At the same time, if I have 125 raised to power 1 over 3, the answer is 5, because 5 raised to power 3 will give me 125. What is my point? My point is, if x plus 1 is a positive number, we can find the cube root. If it's a negative number, we can find the cube root. We will still get an answer that is in the set of real numbers. Assuming it's raised to power 1 over 2 now, that's square root. That means whenever you have square root, it has to be greater than 0, because if you have square root of minus 4, for example, the answer will be 2i, or plus or minus 2i. But don't forget, I is not in the set of real numbers. So assuming square root, you will have to consider the case that everything under the square root has to be positive. But since it's cube root, we don't need to consider any case. So the domain is basically R. Any value you put inside this, it will work. Do you get my point? You will get a real answer. Or if you want to write in interval form, minus infinity to infinity. That is what we have in this case. Now let's look at the final stage. We want to find range. Now they'll say find the range of the following functions by drawing the graph. Actually, they want us to draw the graph of this and then find the range. So there are various ways of drawing a graph. You just need to find the table of value, then you draw the graph and you'll be able to find the range. Now I won't draw the graph, but I will show you. I will use technology to draw the graph. Then you will see how to find the range. But meanwhile, let me show you how to find range manually. You know that we know that what s square will always be greater than or equal to 0 no matter what. S square, by the time the square of any number is always positive or 0. The square of 0 is 0. The square of any number is always positive, because take for instance minus 4 square. The answer is 16. It's a positive number. That's a negative number. I take a negative number, I square it, I get a positive number. If I take a positive number and I square it, I will still get a positive answer. If I take 0 and I square it, I get 0. So what is the essence? No matter the value you take, by the time you square it, it's always positive, greater than or equal to 0. This is what we have. So we have let me add 5 to both sides. I have s squared plus 5 will be greater than or equal to 0 plus 5. Do you get that? Because x squared is greater than 0. Add 5 to both sides. X squared plus 5 will be greater than 0 plus 5. X squared plus 5 is exactly g of x. So this x squared plus 5, this is exactly g of x. That means g of x is greater than or equal to 5. That means, or let me say 5 is less than or equal to g of x. Whichever one I'm writing is correct. If I write 5 first, 5 will be less or equal to g of x. That means g of x is not bounded above. It's bounded above by infinity. So the range of this function is actually, since it's less or equal to 5 to infinity. That is what you have. And beside, if you want to draw the graph, you know how the graph of x squared look like. Actually, the graph of x squared is like this. The graph of x squared is like this, because when x is 0, y is 0. Now that I have x squared plus 5, the lowest value of x squared is 0. So 0 plus 5 is 5. So that means the graph will be like this, where this place will be 5 actually. So this is 5 and upward. That's why we have the range. You will have to measure the y-axis. The y-axis will tell you the range of a function. Meanwhile, let's draw it. You can just come online and search graph online. You can see. So I use Desmos. Now I want to draw s squared plus 5. S squared plus 5. So um you can see how the graphs look like. That's what we have there. You see that the graph starts at the lowest point on the graph is 5. That's on the y-axis 5, and it goes up to infinity. That is the range of the function. That's the range of the function. Let's go to the second example. For the second example, I have b h of x to be equal to minus 3x squared plus 1. So basically, again, let me show you how I can find the range without drawing the graph. Of course, we know that x squared is always greater than or equal to 0. We know that. Now, multiply both sides by minus 3. This is minus 3x squared. Whenever you multiply with a negative number, the inequality will change. So minus 3 times 0 will actually still give me 0. So minus 3x squared is less or equal to 0. I will add 1 to both sides. Minus 3x squared plus 1 will be less or equal to 0 plus 1. Minus 3x squared plus 1 is exactly h of x. So this will be less or equal to 1. So that means the range, you can see that it is bounded above but not below. Less or equal to 1, that means it is smaller than or equal to 1. So that means it starts from minus infinity, then stop at 1. Since it's less or equal to, you have a closed interval here. So if I want to draw the graph of this, it's not also very difficult, but let me use Desmos to draw it. Minus 3x squared plus 1. So I can draw the graph here. I'll just need to type in the function minus 3x squared plus 1. So I can um I can erase x squared plus 1 so that you will see what the minus 3x squared plus 1 is saying. You see how it goes down. This one goes to goes below, that is till minus infinity. The highest point on the graph is 1. You can see that 1, then it goes down to infinity, downward like that. That's no end if you continue going down. So that is 4. That's down like that. That is the graph. So the graph, from the graph you will see that the range starts from minus infinity down up to 1. That's the range of the second one. Let's come to the third example. The third one says k of x to be equal to ln of 3x plus 6. Actually, for logarithm function, Logarithm function also span the whole set. Since it's a logarithm function, lim, since it is lim, the range is basically the set of real numbers R. That is, the range span from negative infinity to infinity. So let's confirm what I have written. And again, if I want to remind you of the domain, this is, we are looking for range here. If I want to remind you of the domain in this case, um, don't forget I told you in the domain, the what is after the argument of the lane must be greater than 0. That means if I want to find the domain here, 3s plus 6 must be greater than 0, and if we solve this inequality, you will get s to be greater than minus 2. So s must be greater than minus 2 before this function can be defined. Now let's draw the function on decimals. We have ln of 3s plus 6, ln of 3x plus 6. So now let's see what we have here. So basically you see that the function goes down. It goes down. You might be thinking it stop here, but if you look at the value, you can see, if you look at the value of the function, you see when s is minus 2, it is undefined. What it means by undefined here is that the answer is negative infinity. When s gets to minus 2, it is negative infinity. And if you look up here, the function goes like that, and it will continually go like that no matter what, no matter the way I assume it. It will go up and up and up, and it will get to infinity. When x is infinity, y will also be infinity. That is why I have written that, or I said that. That's why I said the range is from negative infinity to infinity. Now the fourth one, the fourth one, v of x, that's minus cos 2x. In reality, um, let us try to find this value as well before we draw it. Let's try to find the range. Cos of any value, both sine and cos actually, they are always between minus 1 and 1. There is no value of cos. Press cos any number. There is no value of cos that will be greater than 1 or that will be less than negative 1. They are always between minus 1 and 1. Do you get my point? So if you multiply minus, if you use minus to multiply through, this one will become 1. And since you are multiplying with minus, this will change to greater than minus cos 2x greater than or equal to minus 1. I can rewrite this from here. I have minus 1 less or equal to minus cos 2x less or equal to 1. So that means minus 1 is less, or this is exactly v of x is less or equal to v of x less or equal to 1. So that means the range of that value is actually between minus 1 and 1 in closed interval, because I have less or equal to. If I draw that on the graph, minus cos 2x, you will see what I will have, minus cos 2x. You see how it goes? You see the value is just running between minus 1 and 1. That is the basic point of the story. That's how the cosine functions look like. It will just run between minus 1 and 1. The highest value here, or the highest value here is 1. You see, pi over 2, 1 is the x. Don't forget, to get the range, we are looking at the y-axis. So that's 1. If you go to the next one, it's also 1. If you come down here, negative 1, negative 1, negative 1. So the highest value is 1, the lowest value is 1. That's the range of that function. Now the last one there, 4 plus 2 sine x. That is the next one we want to do. 4 plus 2 sine x, number 4. That'll be the last one. E. We have, let me just call it any function. 4 plus 2 sine x. As I have explained earlier to you, sine x is actually between minus 1 and 1 multiplied through by 2, I have minus 2 less or equal to 2 sine x less or equal to 2. Add 4 throughout. When you add 4 here, you have 4 minus 2 to be less or equal to 4 plus 2 sine x less or equal to 4 plus 2. You see, I have added 4 throughout. 4 minus 2 is 2 less or equal to 4 plus 2 sine x is actually h of x less or equal to 4 plus 2, 6. So that means the range of this value is 2, 6 actually. And if you draw the graph, it will give you the same thing. 4 plus 2 sine x, 4 plus 2 sine x, 4 plus 2 sine x. You see that? Uh, Let me clean this cos 2x. You see where it falls, the biggest value is 6. You can see that the biggest value of sine x is 6. The smallest value is 2, as seen on the y-axis. That is the range of that function. Kindly subscribe to my YouTube channel. Thank you very much.